Hey, Ivy Pre-Cal. So, in the last few lessons that we have done together, we have really been taking a look closely at rational functions, right? And we've done a lot of graphing with rational functions. In this lesson, we are going to be solving rational equations in one variable. Okay, so finding solutions, right? Think about what that exactly means. Oh, you're finding x-intercepts or zeros, right? This is where y equals 0, right? So we've been doing variations of this, but you've been doing it in terms of graphing, and now we're going to look at equations and actually think about how we can solve them. So it might not just be a pure like ratio of polynomials, right? So I could be looking at it in parts now. This is part 2 of your homework that practices with specifically with solving equations, rational equations in one variable. So after you complete this, I encourage you to start working on some of these that you can come to class. And I would say like part 1 and part 2 are ones that you might have want to start to look at prior to coming to your first live session this week. So let's get started. Hopefully you either have this PowerPoint printed out or you have your notebook and maybe you have your notebook ready to go. So here's our first example. And so we have x plus 1 over x minus 4 equals 0. And we want to solve this. And I really want to emphasize that we're solving over the set of real numbers. Right? So that's usually what we assume unless it says otherwise, but I want to emphasize that we are solving over the set of real numbers. Like we're not getting imaginary solutions here. So let's see. What could I do in order to solve this? And there's a variety of things that I could do first, but I'm going to encourage you that the first thing that we want to do is I'm actually going to just get rid of this denominator, right? And how an equation works, as long as you do the same thing to every single part, it's legal. It's allowed. So I'm going to go ahead and just multiply through by x minus 4. When I do that, I get x times x minus 4. Oh, check that out. That cancels. Plus 1 equals 0. And just like that, I'm no longer dealing with fractions. Right? So now I've got x squared minus 4x plus 1 equals 0. Right? And our first thought should be, I'm going to go ahead and try to factor this. But I probably get stuck. Right? So we use our old friend, the quadratic formula. I don't want to write right there. Why does it do that? It's so strange. It's going to do it again. I'm going to use the quadratic formula. You know what? I think I'm going to start with the discriminant just to make sure that I don't get a non-real solution here. So I'll do b squared is 16 minus 4 times a times c, which perfect. That gives me 12, right? So I'll get plus or minus the square root of 12. So the opposite of b, 4 plus or minus the square root all over 2a. So let's simplify this a bit. I get 4 plus or minus the square root of 12 is, right, that's 4 times 3, so 2 root 3 all over 2, and that simplifies more to 2 plus or minus root 3. Right, so I get these as my two solutions. Let's check these. Let's pull out our friendly calculator and actually check these. So in my calculator, I'm going to store these instead of having to plug them in. So I'll say 2 plus the square root of 3. And if I push this button right here, this is STO, and then I'll do alpha A. So now that's the first one, right? And then anytime I recall that, if I do alpha A until I clear my calculator and push enter, oh, look, there it is. And then I'll do 2 minus root 3. And then I will store that as alpha B. Oh, no. No. Alpha B. And there we go. So now they're stored. So I could go back into this. And, I mean, I can even plug it in right here. Right? I could do alpha A plus 1 over what would this be? Alpha A minus 4. Well, I get 0. I could do alpha B plus 1 over alpha B minus 4, right? So I'm not then like typing it in and trying to figure out where all the parentheses are. Super encourage you to use that. So the limit of this of x plus 1 over x minus 4 as x goes to infinity. So as x gets bigger and bigger, and think about this logically. I'll put the graph up here in a moment, but think about this logically. As your x gets bigger, this number is going to get really big, right? This is going to become a smaller and smaller fraction. So at some point, it's not going to increase quite as quick, but it's going to keep getting bigger, right? So the limit is going to go to infinity. Over here, as this gets smaller, like again, you're going to get a fraction here, but your fraction at some point is going to be so minuscule, it's like not even relevant to us, right? It's just the fact that this is getting bigger and bigger. I'm sorry, smaller and smaller, like closer and closer to negative infinity, right? So thinking logically through that, like what is actually going to happen as you get bigger values? Like, yeah, we have this fraction, but it's so small, especially the bigger this number gets. Right? Like if I have 1 over 1,000, who cares, right? Like I might be adding that. It's still going to be getting bigger overall because of this. So if I guess I don't need that right now. If I go ahead and look at the graph of it, right, you can see what the end behavior is, right? And these are probably A and B, right? 2 plus root 3 and 2 minus root 3. What about this second one? So I'm going to actually change this to be a plus sign. So let's go ahead and solve this and make sure you change yours to be a plus sign as well. And I want to start it the same way. Like, let's just get rid of that denominator. Like, a lot of us don't love fractions. So this right here, I hope that we recognize is just x times x plus 2. Right? So I'm going to multiply through, and we did this last year when you talked about like complex fractions, right? And we tried to get rid of that. Remember like the minor denominator that was everyone's favorite? We want to multiply through by the least common denominator so we can get rid of it, right? So I'm going to actually multiply through by x times x plus 2. When you do that, this x is going to go away, and I'm going to end up with x plus 2 times x plus 3. I could write it out, but let's just think logically through it. Plus, the x plus 2s are going to cancel, so I'll just have a 3x. Plus, that's just going to be 6 equals 0. Right? And now let's like expand. I no longer have the fraction issue, so let's just use our math knowledge. I can't even think of the word. But the double distribution, right? Let's use FOIL to multiply this out. X squared plus 5x plus 6 plus 3x minus 6 plus 6 equals 0. So I'm going to get x squared plus 8x plus 12 equals 0. Does this factor? 4 and 3, 6 and 2. X plus 6, x plus 2 equals 0. And we get x equals negative 6 and negative 2. Right? Those are my two solutions. Do they work? I think so, right? Should we plug them back in? Let's see what happens when I plug it back in. I'm gonna do it without a calculator. I'm gonna think. I wonder if you guys see anything that might be an issue. So if I go ahead and I plug in negative 6, I get negative 6 plus 3. We'll check x equals negative 6. Negative 6 plus 3 gives us negative 3 over negative 6 plus 3 over negative 4 plus 6 over 36 minus 12. What's that? 24? right? So all's fine, right? I get 1/2 minus 3/4 plus 1/4. 1/2, let's see how my mental math is. Minus 2/4. Oh, isn't that 1/2? 1/2 minus 1/2 equals 0. I'm checking for a reason, and maybe you recognize why I'm checking already. Let's check what happens when we do x is -2. I get -2 plus 3 is 1 over -2. I get plus 3 over 0 plus 6 over 4 minus 4 is 0 equals 0. Wait a minute. What just happened? Is that allowed? Is that okay? Can you divide by 0? No. You can't do that. We've known that for a long time now, right? This is not allowed. No. You can't do this, right? This is not actually a solution, right? That is extraneous. That is not something that actually works for us, right? So our only solution is x equals -6. Check your solutions. Look at them. I'm not saying necessarily that you need to thoroughly go, and this is great, but thinking through, like, when I put that back in, does it have any issues? Maybe I should have started off and immediately said x cannot equal 0 and x cannot equal to -2, right? Those are kicked out of my domain. So if I end up with them, they are not solutions. -6 is fine, right? If I'm going to go into my calculator and look at this is what I'm going to do. Ooh. Having some technical difficulties. Can I get it back? Yes, I can. This is what I'm going to do. So I'm going to actually put each one in here instead of trying to like group everything. So I'm going to do x plus 3 over x, 3 over x plus 2, and then 6 over x squared plus 2x. Okay. In y4, I'm going to go ahead and do vars, y vars function, get y1. Oh no, sorry. In y4, vars, y vars function, grab y1, plus vars, y vars function, grab y2, plus vars, y vars function, grab y3. All right, I'm adding them all up. And then I will unhighlight these because I don't want it to graph those. I only want it to graph the sum. And then I will go ahead and graph and we can see what it looks like. Oh, see? I wonder, do you think maybe that y-intercept, if I trace it? Not y-intercept, I meant x-intercept, right? Wasn't it 6? -6? Oh, I can see it's pretty close. Maybe I should actually trace it. Second trace, 0. Remember how to do this? And you go left bound. My y value is positive. Enter. Go below it. I need my y value to be negative. It is. Enter. Enter. Oh, look, -6, 0. There's not one at -2. See? That wasn't real. Right? It's not actually a real one of this. So, right, that's just a good way to graph it. So solving. So let's take this a step further and let's look at an application. Oh my goodness. Let's clear this and let's look at an application. So concentration. So concentration is the amount, oh my gosh, the amount of pure acid over the total amount of mixture. So how much pure acid must be added to 50 milliliters of 35% acid solution to produce a mixture that is 75% acid? So X we're going to say, like, we're defining it as the milliliters of acid added. And our goal is to determine the amount of pure acid over the total amount of mixture. So we want to set up an equation where C of X is the amount of mixture you want, right? And then we're going to solve this algebraically. So this right here is my equation. So X plus 17.5, right? So how much pure acid has to be added to a 50 milliliters of 35% added? So I'm sorry, of acid. So if I go ahead and I do 50 times 35%, right? So 50 times 0.35, that's where that 17.5% is. That 17.5 is coming from. It's the amount of pure acid, and it's asking you how much needs to be added. So I already have 17.5. That's why it's 17.5 plus however much I'm adding. The total is 50. That's what I started with, plus however much I'm adding. X is the pure acid that's added, right? That's why it's in the numerator and the denominator, because it's being added to the total and it's being added to the amount of pure acid. We want it. Our goal is to get it to be 0.75. So when I set up this ratio, that it is 0.75. And then we want to go ahead and let's solve this analytically or algebraically and do like the math of it. And then let's also look at the graph of it. So just to reiterate, X represents, it is the pure acid that is added. We already had 17.5 milliliters of pure acid, and that came from, we have 50 milliliters, and 35% of that is pure acid. So when we went ahead and I did that up there, but 50 times 0.35 gave me 17.5. So I'm saying, well, how much more pure acid do I need to add for it to be the amount of pure acid over the total, right? Which was 50, but I'm adding X to that also to get me to 0.75, to get me to a 75% concentration. So when you solve this, I shall go over here, X plus 17.5 over X plus 50 equals 0.75. I'm going to go ahead and I'm actually going to multiply both sides by that denominator, right? I'm multiplying through by the denominator just like we did before. So times X plus 50. Go ahead and distribute into that. X plus 17.5 equals 0.75X plus 37.5. And then it's a two-step equation from this, right? So I can go ahead and subtract 0.75, right? We know that one. 1 minus 0.75, dollar minus 3/4. 0.25x equals, when I subtract 0.75 from that side, I get 20, right? So I'm subtracting 0.75x and I'm subtracting 17.5. That's a 7. Sorry. It got messy. Divided by 0.25. Divided by 0.25. That's just like multiplying by 4, right? So if I do 20 times 4, this is like 20 divided by 1/4, or 20 times 4, I get 80 milliliters. Right? So that is algebraically how I would go about solving this. Graphically, let me just clear this. I'm gonna go ahead and say X plus 17.5 divided by X plus 50. And let's see where that intersects with 0.75. Go ahead and graph it. There's 0.75. Oh, right? We know that it's 80, so I probably need my X max to be more. maybe don't need this to be so large. Let's see. I do see the intersection a little bit. Let's change the window a little bit more. My y minimum probably doesn't need to be that small. Let's do like -2. There, now we're going to be able to see it. Right, so I can do that second trace intersect. Go over to that point of intersection. First curve, second curve, guess. Oh, look, 80. 80 milliliters is going to give us a concentration of 75% pure acid. All right. So, pretty cool. Oh, I guess I did that, didn't I? So in this video, what we did was we're still working with rational functions, but with more of a focus on solving as opposed to just graphing, right? So solving rational equations in one variable and really pulling some of the prior knowledge that you have in general about how to solve equations and how to check for your solutions and apply some of this knowledge and information. And so what your job should be now is to make sure that you are working through part 2 and as well as part 1 so that you're coming to class during our first live session ready to ask questions and gain some clarification on any of these topics that you have some confusion. So thanks everyone, and we will see you next time.